What's going on, guys? Okay, so I know loads of kids struggle with the conservation of momentum questions, so this is the reason why I've made this video, so that I'll walk you through some past paper questions all about the conservation of momentum. Right, so if you don't know what the momentum is, first of all, momentum is going to be a measure of an object's mass times by its velocity. The greater momentum of an object, the harder it is to stop. The principle of conservation of momentum simply states that the sum of the momentum before the collision, yes, the total momentum of the system before the collision is actually equal to the total momentum of the system after the collision, providing that there is no external forces such as friction. So if I was to put that down, so in simple terms, we can say that the sum, there we go, of the momentum before is equal to the sum of the momentum afterwards, yes, in any single collision, provided that there's no external forces acting such as friction. So don't forget, this symbol means sigma, which means the total. Okay, so let's just try and walk you through this problem over here. And obviously, if you don't understand the principle of conservation of momentum, watch my video. I'll put it in the link below. Click on it, make sure you watch that. And obviously, if you don't understand what momentum is or the formula P is equal to mv, there's another link down below. Just click on that and then watch this video afterwards, because obviously you have to understand the theory before we actually tackle the actual problem. So let's tackle the problem, guys. Okay, so question 1. The diagram shows a car and a lorry about to collide. Okay, so we've got a lorry over here and a car over there. When they collide, the two vehicles become tightly locked together. Calculate the speed of the vehicles immediately after the collision. Okay, so first of all, they are going to collide and lock together. So the first thing I would draw a before and after stage. So this is before the collision. Okay, and I'll just drop a line over here. After the collision, we recognize that both of them, I'm just going to draw the lorry like this and the car like this. Yes, this is the lorry, here's the car over here. They both collide and they stick together over here. Look, it tells you that they are locked together here, so they both lock together over here. Now, we don't know which way it's going to move, but hopefully we have an idea that this is 9.5 tons. Hopefully it moves in this direction because they collide, stick together, and they move off. Okay, so right now we can then start to tackle the problem. We know that the total momentum of the system before will be equal to the total momentum of the system afterwards. Don't forget, P stands for the momentum. So the momentum before is equal to the momentum afterwards. Right, so this is all beforehand, this is afterwards. They've stuck together afterwards. So the momentum beforehand, our formula for momentum is going to be P is equal to M times by V. So let's work out the momentum of this one. So we're going to work out the momentum of this, yeah? And the question is asking us, when they collide, they become tightly locked together. Calculate the speed of the vehicles after the collision. So we're trying to find out the speed of the vehicles after the collision. Let's put it V here. Okay, so let's look at the principle of conservation of momentum, which we just said. We've already put that down. So the momentum before. So this one is going to be the lorry over here. So it's 9.5. Don't forget, it's the mass times by the velocity. So it's 9.5 times by 20 kilometers per hour. Yes, going this way. And then plus the momentum of the car before, because the car has momentum beforehand, it's going to be 0.5 times by, now careful here, we know it's going to the right, that's the reason why it's at plus 20. So therefore, if this is going backwards, we need to recognize that obviously velocity is a vector. Yes, velocity is a vector. Therefore, I need to put the minus sign here. So minus 40 over here. Very good. That will be equal to the momentum of it afterwards. Right, because they've collided and stuck together, they are no longer separate. So they're no longer separate. So they have a combined mass. How much is the combined mass? Well, it's 9.5 plus the 5. Therefore, it's 10 tons. 10 ton over here. Okay, right. So it's going to be 10 tons over here. So what is momentum afterwards? Well, it's 10, because that's the mass, yes, times by the velocity v, which you don't know. So 10v over here. Right, now on a calculator then, let's try and do this, everyone. So now we have this, we can now do the algebra right now. It's going to be, so 9.5 times by 20, it's going to be 190 over here. So it's 190, tons, kilometer per hour. Yes, because you're multiplying tons by kilometers per hour, so 190 over there, plus, so it's going to be 0.5 times by 40, which is going to be minus 20. So obviously that becomes a negative value of minus 20. so minus 20. I'm just going to remove the unit now. You'll see the reason why. So remove the units. So it's 190 over here minus the 20 here is equal to 10v. So therefore we know it's going to be 170 is going to be, yes, so 190 minus the 20, in this case is 170, is equal to 10v. Therefore finally then v is equal to 170 divided by 10, cancel, it's going to be equal to 17 kilometers per hour. Okay, make sure you're happy with that. So it's going to be 17 kilometers per hour. That's going to be our answer. Let me just double check because it's all gone off here. Let's go for I just double check all my answers. Okay, yeah, so that's going to be my answer. Just double checking, we're getting all my notes up over here. Yes, it's 17, that's my correct answer. That's the correct answer over here. Right, so that's the first question done. Okay, let's try another one. Okay, so that's the first one. Make sure that you recognize that in order to tackle these questions, you are going to be doing a before stage and an after stage, and then looking at the formula, the total momentum before, total momentum afterwards, and then you're going to just do the algebra afterwards. Okay, so that's the first question. Let's do the next one. The more you do, the better that you'll get. Okay, this one over here. Diagram 2. The diagram shows a car and a van just before and after a car collided with a van. So here's a car and there's a van over here before the collision, and it's going to be after the collision over here. They're going to collide. Okay, so this one, okay, they collide. First of all, they do not collide and stick. They are moving off separately. They are moving off separately over here. Use the information in the diagram to calculate the change in momentum of the car. The change in momentum of the car. So what is the change in momentum of the car? Well, don't forget, if you want to work out the change in momentum, don't forget delta P, because delta means change and P is obviously the momentum, is equal to the final momentum minus the initial momentum. Okay, so what is the final momentum? Right, don't forget, momentum is equal to mass times by the velocity. The mass of the car remains, don't forget final, yes, is afterwards. It's obviously going to be the mass of it, so it's given to us over there, 1,200 times by the final velocity, 2, yes, because it was final over here, minus the initial momentum. It's going to be, what's the mass? 1,200 times by the initial velocity, which was 10 over here. Very good. Don't forget it's final minus initial, 1,200 times by 2, minus 1,200 times by 10. In this case, we're going to, it will be, whoops, ooh, where's the pen gone? Yes, the answer is going to be equal to minus 9600 kilogram meters per second. Careful with the unit in this, because you're multiplying kilograms in terms of our units over here. Mass is in kilograms, the velocity is meters per second, hence why it's going to be equal to kilogram meters per second over here. There we go. So yes, that's my answer. My change of momentum is going to be minus 9,600. Yes, oh, I'll put it over here. 9,600 minus 9,600 kilogram meters per second. Excellent stuff. Okay, that's 3 marks. 1, 2, 3. Right, scrolling down then. Let's double check that's right. Yes, that's right. Okay, next one. Use the idea of the conservation of momentum to calculate the velocity of the van when it is pushed forward by the collision. Okay, so we're going to use the idea of conservation of momentum to calculate the velocity of the van when it is pushed forward by the collision. So we're trying to work out this velocity of the van over here. Right, so once again, we recognize we've got to write out the sum of the momentum before is equal to the sum of the momentum afterwards. I'm just going to delete this so there's a bit more space for us over here. Actually, I'll zoom out. It's a bit easier for us over here. So there we go. We should be able to see it all on the screen. So we know that the total momentum before the collision is equal to the total momentum afterwards. So that's always true in any collision. So the sum of the momentum before, actually I'll just put it over there. So I'll just do it over here. So it's going to be the sum of the momentum before is equal to the sum of the momentum afterwards in every single collision. Yes, every time you write this down. The momentum beforehand, don't forget the momentum of the car that before is going to be 1,200 times by 10, yes, plus obviously the momentum of the van beforehand is obviously 0 because it's the mass, which is 3200 times by 0, which makes it 0 over here, is equal to momentum of it afterwards. So momentum of the system afterwards, well, the car hasn't changed its mass, so it's still going to be 1200 times by 2, because the final velocity is 2 of the car. But the momentum of the van we don't know, so we're going to put plus, what's the mass of the van? Well, it remains the same, so it's going to be 3200 times by the value of the velocity, which we don't know. We're going to leave it as v. Now we're going to solve this, so 1200 times by 10, yes, on this side, and then we're going to subtract from it 1200 times by 2, okay? That will be equal to 3200v. Yes, make sure you're happy with the algebra. And then scrolling down over here, finally then, so on the left hand side it becomes 1200 times by 10, it's going to be 12000 minus, so 1200 times by 2 is equal to minus 2400 divided by 3200. Yes, so that so 1200 minus 2400 divided by 3200 over here. Oops, 12000 minus 2400 divided by 3200. Yes, I'm getting the value of v to be equal to 3. There we go, 3 meters per second. Double check my answer. Yes, it's 3 meters per second over here. So that's just 2 marks. You might be thinking that's quite a lot for 2 marks, but obviously we've done quite a lot of calculations, but you should be fine with that. So look, the main link is this. Recognizing you've got to write the sum of the momentum before is equal to the sum of the momentum afterwards. And that is the same in the previous question at the top. Look, we had to look at that. The sum of the momentum before is equal to the sum of the momentum afterwards. So we've done that twice. Okay, now scrolling down then, let's go for the next one. Okay, so here's the next one. The drawing below shows 2 railway trucks A and B moving in the same direction. Truck A of mass 1,500 is initially moving at a speed of 8 meters per second. Truck B of mass 2,000 kilograms is initially moving at a speed of 1 meters per second. A truck A catches up and collides with truck B. They have now coupled together and they've stuck, yes, and they've moved off. Calculate the initial momentum of truck A. Right, initial momentum of truck A. Well, momentum is equal to mass times by velocity. So the mass of it is going to be 1500 times by 8 in this case. So 1500 times by 8. The answer is going to be 12000. Yes, double make sure. Yes, that's my answer. Very good. Calculate the initial momentum of truck B. Truck B, well, look over here. Once again, momentum is mass times by the velocity. So the mass is going to be 2000 times by the velocity of it is going to be 1. So it's going to be 2000 in this one over here. Yes, so it's going to be 2000, yes, kilogram meter per second. Calculate the total momentum of the system before the collision. Right, so this has a momentum before. So this is the before stage, and obviously this is the after stage. So obviously this is before. So this momentum plus this momentum is going to be how much? It's going to be 12,000 plus the 2,000 over here. It's going to be 14,000, yes, going to be in total. So it's going to be 12000 plus 2000 in this case is equal to 14,000. Excellent. Kilogram meters per second, because don't forget momentum is measured in kilogram meters per second. I know the question at the start was a bit different. It was tons, kilometers per hour, but yes, in general it's kilogram meters per second. Scrolling down, calculate the speed of the coupled trucks after the collision. Calculate the speed of the coupled trucks after the collision. Well, don't forget, you know that the sum of the momentum before, so let's just do it very slowly. The sum of the momentum before is equal to the sum of the momentum afterwards. So the momentum beforehand, don't forget truck A, we've just done it already. Look, it was the momentum of truck A before, which was 12000, plus momentum of truck B before, 2000. But now don't forget they've collided with each other and they've stuck together. So there's not 2 separate masses at the end, there's only 1 mass now because they're moving off together. So they have a combined mass now. So the final momentum is going to be the combined mass, which is going to be, so it's going to be 1500 plus 2000, yes, it's going to be 3500. yes, is equal to 3500. Yes, because the mass of truck A we said was 1,500, truck B was 2,000, therefore it's 3,500 in total, times by the final velocity, which we don't know, v, because we know they both collide and they hit with each other, but we don't know the final velocity. If I was to draw the arrow over here, we don't know the final velocity, we don't know it. That's why we're just labeling it as v. So there we go. So now we're going to solve this. So it's going to be, we already did this earlier. Look, the leading question. The momentum is, in total of these two, is going to be 14000 is equal to 3500v. And therefore v is equal to 14000 divided by 3500. So my answer is going to be 14000 divided by 3500 over there. It's 4. So my final velocity is going to be 4 meters per second. Very good. This is 5 marks. 1, 2, 3, 4, 5. Yes, the double check. Yes, it's going to be 4. Excellent stuff. Make sure that you've got this right. Tricky question, but obviously keep practicing, guys, and you should be fine. Okay, next question. Figure 4. The figure below shows a skateboarder jumping off a skateboard. Right. The skateboard is stationary at a moment the skateboard jumps. The skateboard moves backwards when the skateboard jumps forwards. Explain why, using the idea of momentum, why the skateboard moves backwards. Right, the simple idea is going to be, it's like me in this chair. If I was to get up, yes, and move off the chair, yes, you can see that the chair moved backwards. So if I move forwards, the chair moves backwards. It's because of the conservation of momentum. So don't forget, beforehand in this scenario, this is afterwards he started to move, but before, obviously, he's not moving. So at the start, so this is the skateboard, and the person is going to be on there, yeah, at the start. So initially he's not moving, then obviously if he moves with this momentum to the side, well, this momentum, well, the skateboard has its own momentum in this direction. So it moves this way, and then obviously this momentum here will cancel it out, because you know that the total momentum before the collision was 0, yes? So before there was no momentum, and afterwards there should be no momentum as well, because this momentum will cancel out this one. That's the reason why, because initially right now, look, the momentum of the system is 0. If I get up, yes, my chair moves backwards. Yes, when I get up, my chair moves backwards because I have moved with momentum in this direction. The chairs move back with momentum in that direction. Right, okay, so let's try and do this then. So first of all, using the idea of momentum, we need to recognize that the momentum of the skateboard is equal to the momentum of the skateboarder. Yes, the skateboarder. That's going to be the key thing, the momentum of the skateboarder over here. That's the main thing at start, yes? So obviously, and before he actually jumped, what was the total momentum? Right, so look, before he jumped, this is the first point, before he jumped, the total momentum of the system was 0. So before he jumped, the momentum of the system was 0. Was 0 in this case. It was 0 in this case over here. Yes, and then afterwards, and then obviously when he jumped, he had forward momentum, but when the skateboarder moved forward, so don't forget that here's the skateboarder moved forward, in this case, forward, the skateboard, how do you spell skate? A skateboard must have equal momentum in opposite direction. Don't forget, because the skateboard is moving in this direction, the skateboarder is moving in this direction, the skateboard's moving in the opposite direction over here, hence why they cancel out, because it's the direction, because the total momentum was 0 at the start, so these two momentums, if you add them together, will then be 0. Right, okay, let's scroll down then for the next one. The mass of the skateboard is 1.8 kilograms and the mass of the skateboard is 42. Calculate the velocity at which the skateboard moves backwards if the skateboarder jumps forward at a velocity of 0.3. Okay, so look, it says there, the mass of the skateboard is 1.8. So the mass of the skateboard is 1.8 kilograms. I'll just label it on here. The skateboarder, he is 42 kilograms. 42 kilograms over here. Calculate the velocity of the skateboard if the skateboarder jumps at 0.3. So if he's moving at 0.3 meters per second this way, what's the value of this velocity? That's what it's trying to get you to work out. Right, okay, so let's try and do it then. So before and afterwards. So the before and the afterwards here. Okay, so first of all, let's do it. So I'm just going to write down the same thing as I write down every time. It's going to be the sum of the momentum before. The sum of the momentum before is equal to the sum of the momentum afterwards. Right, so beforehand, before he moved, obviously, what was the momentum of the system? Well, obviously you weren't moving at all, so therefore it's going to be 0. So it's going to be the momentum before is going to be 0. Afterwards, okay, so afterwards, we know that he has momentum forward, yes? Which is obviously the mass 42 times by 0.3. So the momentum of the skateboarder is going to be 42 times by 0.3. Okay, so we've done the momentum of the skateboarder. What about the skateboard over here? Well, it would be the mass 1.8 times by the velocity, which we don't know, v. So it's 1.8 times by v. So this one's going to be plus 1.8 plus 1.8, so that's the mass, times by v over here, 1.8 v. Now we're going to rearrange it then, so taking 42 times, so we're going to go 42 times by 0.3, it's going to be equal to 12.6. So this is going to be 12.6. So 0 is equal to minus 12.6 plus 1.8 v. Yes, over here, taking the 12.6 across, so 12.6 across is equal to 1.8 v, and therefore v is equal to 12.6 divided by 1.8. So 12.6 divided by 1.8 is equal to 7. So 7 meters per second. There we go. So this is another example of the conservation of momentum, slightly different to the previous ones that we did. In the previous question, it was, look, over here, two things collided together and stuck together and then moved off. The one before that was going to be two things collided together but didn't stick together. They just separated out. But look, in both of them, momentum is conserved. And the one we've just done right now, we can still see that momentum is conserved, but initially both of them weren't moving, because this is like, initially they weren't moving and then they both move in opposite directions. Okay, right, so, it's still, look, my laptop is, it's not working. Oh, let's go for, sorry, okay, apologies everyone for that one over there. It's 7, very good. Okay, so next one, scrolling down then, 5. 5 is not last one. The roads were very icy. An accident was recorded by a security camera. Okay, car A was waiting at a road junction. Car B was traveling at 10 meters per second, went into the back of car A. This reduced car B's speed to 4 meters per second and caused car A to move forward. Okay, so car C was waiting at junction. Car B was traveling towards it, went into the back of car A. And obviously this reduced the car's B speed to 4 meters per second, which caused car A to move forward. Right, okay, so over here. The total mass of car A was 1,200 kilograms and the total mass of car B was 1,500 kilograms. Write down the equation you need to work out momentum. Right, momentum is equal to mass times by the velocity. Okay, there we go, we're done. Calculate the change momentum of car B in this accident. So change momentum is the change momentum. So it's your final momentum, so final P minus the initial P. Right, okay, so what is the final momentum? So, don't forget, read it carefully. Car B was traveling at 10, then it knocked in and the car B's speed reduced to 4. So that's the final speed 4. So the mass of car B still remains 1500, so that's the mass, times by the final velocity 4. Good, that's the final momentum, minus the initial momentum, which was going to be 1500, it's the mass again, times by 10 in this case over here. So the change in momentum is going to be this calculation, so it's going to be 1500 times by 4 minus 1500 times by 10. My answer is going to be minus 9,000. kilogram meters per second. That's going to be it over here. 9,000 kilogram meters per second. Okay, right, that was a tricky question because you had to read it carefully to identify what was the final velocity of B compared to the initial velocity. Next one. Use your knowledge of the conservation of momentum to calculate the speed of car A when it is moved forward in this accident. Okay, so we're looking at the final velocity of car A in this accident. Right, so if I'll just draw it out a bit nicer for us over here. We know that car B is here. So let's draw car B. And car A is there. This is my simple diagram. So I'll draw the before stage and I will draw the after stage in this case. So first of all, B was moving at 10 meters per second, 10 meters per second. A was not moving at the start, so car A, yes? So car A went into the back of car A. There we go. Yeah, so car A. Car A is not moving, so the velocity of car A is 0. Afterwards, we know that B is still moving forward, but only at 4 meters per second. Yes, that's the velocity of B, but car A is not moving at all. So the car A is not moving at all. Oh no, it is moving, yes, at a velocity we don't know. We don't know its velocity. But we can see that the mass of car B remains at 1500 kilograms, and the mass of car A, I'm just going to write it here, 1200 kilograms. That's it. So look, once I've done this diagram, it now helps me to solve all the problems. Yes, all the problems that we have. Right, so let's just scroll down once again. So let's just do this then. So let's write down, we're trying to work out the final velocity of car A. Well, we could do it very slowly. So I would write down the sum of the momentum before, is equal to the sum of the momentum afterwards. So the momentum before of the system, the entire system, obviously it's going to be the momentum of car B, yes, plus momentum of car A. So momentum of car B is beforehand is 1500 times by 10. So it's going to be equal to 1500 times by 10. Excellent stuff. Car A has no momentum initially, so it's 0 will be equal to the momentum afterwards. So the momentum afterwards in this case is going to be car B is now same mass, 1500 times by 4. So it's going to be 1500 times by 4. So open bracket, 1500 times by 4. Yes, plus momentum of car A, because now don't forget it hits into car A and car A starts to move. But we don't know its velocity, so 1200 times by V. So scrolling down, it's equal to plus 1200 times by V. Finally, in this case, let's do this then. So it's going to go, this is going to be 15000 is equal to 50 times by 4. This is equal to 6000 plus 1200V. Then rearranging it then, taking this to the opposite side, 15000 minus 6000 divide is equal to 1200V. There we go. So the top line, taking this one over and then we'll take that underneath, 15000 minus 6000, it's equal to 9000 in this case. 9000 is equal to 1200V, and therefore V is equal to 9000 divided by 1200. 9000 divided by 1200, the answer is going to be equal to 7.5. Let me double check that's right. Yes, it's 7.5 meters per second. Excellent stuff. So once again, look, the main thing is that I've identified that the sum of the momentum before the collision is equal to the sum of the momentum after the collision, provided that there are no external forces. That's the main thing. So we've got it once in this question, spot it, yes. We've got it in this question, look, there it is again. So look, if you just crack this actual understanding of the total momentum before, total momentum afterwards, you'll be fine. Look, 1, 2, and look over here, there it is. This is in the next question, 3. And then finally, there it is, question 4. There we go. And then finally, at the start, it's the same thing each time over here. So I hope this was helpful for you, because I know loads of kids struggle in this every year. It's the same thing. Loads of kids don't understand the principle of conservation of momentum. You can't simply look at the revision guide and try and memorize it. You really have to practice solving the sum of the momentum before is equal to the sum of the momentum afterwards, and having one unknown in there. My advice is to always draw a diagram and obviously space out your work looking at the before and the after stage, and then rearranging it to find the variable that you're looking for. And that's it, guys, for another session with me. Hope it was enjoyable for you. Make sure you hit the like and the subscribe button. Hit the notifications as well, because I'll be dropping more videos to help you with your studies. Comment below if you think I've done anything wrong. And yeah, apart from that, good luck, ciao, ciao, and goodbye, everyone. Bye-bye. Stop recording. 3, 2, 1.